All right, ladies and gentlemen, it is 8 o'clock. We are ready to review some fraction-based problems today. That's pretty much what we're doing today. Okay, so we'll kind of do the best that we can with this. The one thing that I do want to make sure that I point out is that if at any point you feel like you are getting stuck on this at all, one of the things that you can tell me is just that, um, you know, um, factoring might be the issue. Okay, so we want to make sure that we understand that factoring here is basically a prerequisite. Okay, so there'll be a lot of times where I'm going to tell you that I'm factoring, but I'm going to go through the factoring a little fast. Okay, if you find yourself struggling on the factoring, my suggestion would be to go back and look at factoring specifically, shore up your skills there, make sure those are solid, and then come back and watch this at a later time. If you're just constantly getting stuck on the factoring, that's a different issue than not understanding what we're doing here. But unfortunately, it is one that does need to be taken care of first. Okay, so make sure that you understand factoring well, and if you're getting stuck on the factoring, that's a different issue. Okay, our first however many problems looks to me to be for 7 are all just simplify problems. Okay, so we need to understand what we're allowed to do when we simplify fractions. Basically, you're allowed to cancel within fractions as long as you're working with all multiplication and division. Okay, so like for example, I cannot, and I'm going to change this. I'm going to repeat it a couple times. I cannot cancel these x squareds. I cannot do that. Do not do that. I'm shaking my head no. No, no, no. Do not do this. Okay, and the reason that we can't do that is because that is part of a larger addition and subtraction expression. So we simply cannot do that. Okay, in most of these cases, before you do any canceling, you need to factor as much as you possibly can first. Okay, so in our numerator, we have first a GCF of 7. That turns it into x squared minus 9. Okay, and then we have a difference of squares rule with that x squared minus 9. That's going to turn it into x minus 3 and x plus 3. Okay, that's our numerator. Our denominator is simply a door problem. So we're looking for numbers that multiply to the last and add to the middle. Those would be 4 and 3. So we simply jump right to x plus 4 and x plus 3. Okay, now if you basically consider those parentheses like they are their own single individual numbers, okay, then it's one big multiplication expression, right? On the top, it's 7 times the first parentheses times the second parentheses. On the bottom, it's the first parentheses times the second. So as long as we cancel out an entire parentheses, we are good. Okay, so the one thing that does cancel out here are those. Okay, so my final answer would be 7 times x minus 3 over x plus 4. You don't have to distribute, okay? If you did distribute and got 7x minus 21, that would totally be fine too, okay? On to the next one. Now, here's what's great. This problem looks significantly more complicated. Nope, not really. There is just a lot more factoring for you to do. Okay, so my top left is a door problem. We're going to look for numbers that multiply to the last and add to the middle. Okay, those would be 9 and negative 5. In the bottom of my first fraction, I have a greatest common factor of 4. 4 and 20 both divide by 4. So I get 4 times x minus 5. Okay, second fraction. GCF of 3 in my numerator, and squares rule in my denominator, x minus 9, x plus 9. All right. Now, when you're looking for what can cancel and what can't cancel, you may cancel within the same fraction, you may cancel diagonally across fractions. In short, if it's your numerator and denominator, you can do it. Okay, and the reasoning being, this whole numerator is just multiplication. Same thing with the whole denominator. So we could reorder them and line them right up with each other and get them to cancel. We're just not going to do the reordering part. Okay, so for example, plus 9 and plus 9, x plus 9, x plus 9, those cancel, even though they're in different fractions. One's in the numerator, one's in the denominator. Totally okay. X minus 5 and x minus 5, those are in the same fraction. They still cancel. Okay, nothing else does. So I get 3 times x minus 1 over 4 times x minus 9. And again, you don't have to distribute for your final answer. I usually just leave them just like this. If you want to distribute, go right ahead. If you don't, that's okay too. Works either way. Okay, so really, the one thing I kind of want to point out is that first problem and this last problem were really pretty much the same problem. It's just a whole lot of factoring and then canceling stuff that's in your numerator and denominator. That's the same. Pretty much the idea. Okay, now we get to the fun stuff, or the not so fun stuff, depending on how you look at it. Okay, when we get into addition and subtraction, we need a common denominator. Okay, so looking at getting a common denominator here, it's typically a good idea to write what your least common multiple or your least common denominator is over on the side. Okay, you don't have to do that, but it's not a bad idea. Okay, there is no way to get n minus 1 and n minus 3 to match through multiplication, right? Because if we multiply, for example, don't write this down, this by 3, we would have to distribute it to the n and the negative 1. So we'd get our last number to match, but then we'd have a 3 in there that we don't want, okay? So in the end, the least common multiple is just this. Okay, so what we're going to do is get a common denominator, okay? And when we get a common denominator, all we're going to do is multiply that first fraction by n minus 3. Oops. And that second fraction by n minus 1. Okay. So when we do that, in our denominators, okay, and I will try to show a good bit of work here, we're not going to actually do the multiplication in our denominator. You can. It's not necessarily going to hurt anything, but if after you combine your fractions, any canceling were to happen, you would want that to be factored anyway. So I'm going to totally leave those just as they are. Okay. In our numerators, what we're going to do is we're going to multiply. So I'm going to show this over on the side, okay, because I'm kind of running out of room here. Okay, basically in that first fraction, we're going to take n minus 3 times n minus 6. Okay, and we're gonna simply multiply those together. Okay, that's FOIL, right? So I'm gonna get n squared minus 6n minus 3n plus 18. Combine like terms, that's what I get when I multiply them together. Okay, I'm going to do the exact same thing over on the second two, right? I'm going to do my n minus 9 times my n minus 1. Now, guys, you probably don't have to show as much work as I did, and you probably had a little more work. You probably left yourself a little more room to actually show work. I'm just kind of doing this because I'm on the iPad, and I want to make sure we see the work a little bit here. Okay, so I'm basically multiplying the top right, the numerator of my right side fraction. Okay, so I get n squared minus n minus 9n plus 9, or n squared minus 10n plus 9. Okay, I'm going to stick those things up in my numerators now. Okay, so I did the multiplication over on the side. You guys don't ever have to do multiplication over on the side, but you're totally welcome to. Okay, now, here's where the tricky part is going to come in. Okay, the tricky part is going to come in when we do this subtraction. Okay, so we're going to take this term by term. Okay, our new fraction is going to have a denominator of n minus 3 times n minus 1. Okay, because you don't change the denominators here. Okay, however, I'm going to take the rest of these term by term. Okay, so we're always subtracting. So we're doing n squared minus n squared. Okay, that is 0. Next term, we're subtracting negative 9n minus negative 10n. Okay, so that's going to like turn it into negative 9n plus 10n. That gets us just n. Okay, I'll even write it in green so you can see that green little drawing there is where I got that from, okay? And then I'm doing 18 minus positive 9. That's just regular 9. Okay, so I get n plus 9 over n minus 3, n minus 1. There is no simplification I can do there. There's nothing. Okay, it's just this. I cannot cancel n's. I can't cancel 9 over 3. There is nothing I can cancel there because the only way I could do it is if I canceled the whole parentheses. Since I can't cancel either of those two whole parentheses, there's no canceling that I can do. Okay. Number 4, no addition and subtraction. We're not actually adding or subtracting fractions here. In fact, this one, all of the factoring is done for you. Okay, so the reason I put this problem in here, and the reason I've given you similar problems multiple times, is just so you understand what cancels and what it cancels to. Okay, so first things first, b plus 4 and 4 plus b, they cancel, just like regular, right? The reason is if you switch addition, doesn't change anything, right? B minus 3 and B plus 3, those do not cancel. Those will not be the same number. Okay, so those are not going to cancel, right? 1 minus 3 is negative 2. 1 plus 3 is 4. Those don't cancel to 1 or negative 1, so that's not going to work. The last one, 1 minus b and 2b minus 1, this flipped subtraction, it does cancel, but it cancels to negative 1. Okay, where you put that negative 1 doesn't matter. Your numerator, your denominator, just not both. Okay, one or the other. Okay, so my final answer here is, could be written a bunch of different ways. I'm going to write it this way. Okay, and that would work great. Any other variation of this, there's tons of variations of here that would work. The only reason this problem is on here is to remind you that if you have subtraction, but it's in the wrong order, you can cancel it. It just cancels out to negative 1. Okay, flipped addition always cancels, and it just cancels to regular 1, so I didn't need to write anything. Subtraction and addition, if it's two separate operations, they don't cancel. Okay. 36 over x minus 6 minus x squared over x minus 6. Okay, first thing we got to do here, bring them together. Okay. Hang on, I got to check on my kid real quick. I'll be back in probably 30 seconds. All right, sorry about that. We had a dropped stuffed dog, so that's upsetting. Can understand that, right? Okay, so back to this. Where we're at now, we cannot cancel anything. We can't cancel the 36 and the 6, nothing, because it's got addition and subtraction. That's what we got to do is we got to factor first. Okay, we can do that by using squares rule. 6 minus x, 6 plus x minus 6 in the denominator. Okay, now this is really just us bringing back the last problem we did, right? Okay, so this is why I pointed out in the last problem where you could cancel that flip subtraction. Okay, so that, what I'm circling in yellow there, that was able to cancel out to a negative 1. It was subtraction, but it was in the opposite order, so we're able to cancel it. Same thing is going to be true here. We're going to be able to cancel our flip subtraction, but we got to cancel it to negative 1. Okay, so you could leave this as negative 1 times 6 plus x. That would be fine. Or you could distribute that and make it negative 6 minus x. That would be fine too. Both of those would work great. Either answer is fine. Again, flip subtraction. Okay. The other reason I put this in here is because a lot of people see that and they don't factor it properly, right? They write their x's first because that's what we're used to seeing. But if the 36 comes first, you can still use squares rule. You can still use difference of squares, but you've got to write those sixes first. Okay. Last couple here. This is kind of a strange one. Sorry, I accidentally skipped one here. This is a multiplication and subtraction problem. There are many ways you can do this, but the biggest thing is that you have to deal with this multiplication first. Okay, so basically what I try to do is I try to simplify that as much as I possibly can. Okay, so initially what I'm going to do is I'm going to rewrite that 2x plus 2 as 2 times x plus 1. Okay. And I'm also going to put it over 1 because that's what I'm doing in multiplication. Okay. I'm going to leave my minus 2x over there just hanging out. Okay. I'm going to cancel my x plus 1s. I'm allowed to do that. I can cross cancel things, right? Because that's a multiplication problem. Okay. Now I don't have to worry about that problem of getting a common denominator, okay? I get 2x is all I have left from that first bit, 2x over 1, okay? And then minus 2x. Okay, so really all I did to get down to that 2x was just I dealt with that like a regular multiplication problem. I simplified it as much as humanly possible, okay? And then I subtract my 2x, I get 0. Okay, so if you ever see multiplication and subtraction, multiplication and addition, I would say simplify that addition and subtraction as much as, or that multiplication part as much as humanly possible first, and then deal with the subtraction, because then you might not even need a common denominator. Okay, unfortunately on this last one, we are totally going to need a common denominator. Okay, so I have a denominator that I can factor. I should do that first. I get x plus 4 and x minus 1. All right, and then I need a common denominator. Okay, so here's the key. They both have x minus 1s, okay, but this one's got an x plus 4, and the other one doesn't. Bummer. Okay, so all I'm going to do is multiply the first one by x plus 4. X plus 4. Okay, when I do that, I distribute in my numerator, so I get 2x plus 8 over x plus 4 times x minus 1. Same thing over in that second fraction. I changed nothing other than just the initial factoring that I did. Okay. Again, this is where, guys, there's a lot of connecting skills in this unit. So even though this looks like a slightly different problem than some of the ones we did, if you go back to the subtraction one that we did at the start, it's very much the same, right? Now we're just subtracting. We've got a common denominator. We're kind of where we were on this step. Down here, we're just trying to subtract and combine those like terms. Okay, so I still have to be very careful though. Okay, so I'm going to do 2x minus x. That gets me x. And I'm going to do 8 minus 9. That gets me negative 1. Okay, and again, it's still over x plus 4, x minus 1. And here's kind of why I put this problem on here. The x minus 1 on top, okay, and the x minus 1 on the bottom, those do cancel, okay, but our answer is not just x plus 4, it's 1 over x plus 4, okay, because if we had just written x plus 4, that would imply it's up in our numerator. It's not, it's in our denominator, okay, so we can't write nothing in the numerator, so we got to write 1. A little bit of a tricky one, okay. Last two problems, and they are significantly different than all their other counterparts, okay? All of those problems were just simplify problems, okay? This next to last one here is polynomial long division, okay? Part of this here is the setup, right? So your denominator is going to go on the outside there, and inside is going to be 12x cubed, all of that numerator jazz, okay? All right. I'm going to go through it a little quick, but I want to make sure I go really slowly through the first set of steps just to make sure that we're remembering what those are. Basically, you're always dealing kind of with that first term, okay? So with 4x, okay? So right now we're working with 4x and 12x cubed. And basically what you're trying to figure out is 4x times what would get you 12x cubed. Okay, turns out that's 3x squared, right? 4 times 3 gets me the 12. The x times the x squared gets me the x cubed. So that would be 3x squared. I'm going to write that up on top. Okay, then I'm taking my 3x squared and I'm multiplying it by what's on the outside of my root. This is the part where we get pretty similar to what you do in regular long division, okay? So we would get 12x cubed and plus 9x squared. And then you subtract. Again, this is also the same as regular long division. Okay, you would subtract here. Okay, so we subtract, and those first two will drop to 0. The second two, it's negative 19 minus positive 9. That's negative 28x squared. Last step in that first cycle, bring down the negative 25x. Bingo. Okay. That once you've got that first cycle down, to me the process just repeats. Okay, you have to a little bit understand how it repeats, but really it's doing the exact same thing over and over again. Okay, so I can pick up the pace a little bit here, hopefully. Basically now you're working with 4x and negative 28x squared. Okay, so now you're doing 4x times what gets you negative 28x squared. Okay, now all of this stuff that I'm writing over on the side, you guys don't ever need to write it. I'm just showing you what my thought process is. Okay, so I'm going to do the that's going to be negative 7x, so I'm going to write that up top. I'm going to do negative 7x times 4x plus 3, so I'm basically multiplying by what's on the outside. That gets me negative 28x squared minus 21x. Here's a big place where people typically go wrong. Okay, we are subtracting. You are always subtracting. So as always, yes, those first two go to nothing. Okay, but those second two, it's negative 25 minus negative 21. Okay, so that's like negative 25 plus 21, same idea, right? So I get negative 4x. Bring down the next term. Lather, rinse, repeat one more time. We'll go in this fancy yellow color because, I don't know, I really like it. Okay, so now we're doing 4x into negative 4x. Well, that's negative 1. Multiply negative 1 times 4x plus 3. I get negative 4x plus 3. Do the subtraction. I get, looks to be negative 13. Okay, so then I do minus 13 over 4x plus 3. That's what I do with my remainder. Okay, your remainder goes as a fraction over what was out in front. Okay, polynomial long division, guys, you really got to get that initial process down. Okay, once you get kind of that process of, okay, I'm working with the first part and I'm looking for something that multiplies to, right? So when you get kind of that first cycle down, after that it's just repeating and then being extra careful with your negatives. Okay, last problem is this one. And basically what you want to do here is you're solving for x now. Okay, so you've kind of got a different set of rules. You can multiply by whatever you want. That's kind of cool. And basically what you're going to try to do is get rid of these fractions as quickly as humanly possible. So you're going to figure out, okay, what would be my common denominator if I was getting one? Well, the only two fractions I have both have the same denominator, so I guess it would be x minus 2. What you're going to do is this. I'm going to try to color code this a little bit. Okay, I'm going to rewrite my original problem in black. Okay, and then in red, I'm going to show you what I'm going to do. I'm multiplying each of my numerators, just numerators only, by x minus 2. Okay. Then, Ali pointed out a boo-boo on the last one. Did I make a boo-boo on the last one? Oh, yep. You're right, Ali. Thank you. I knew that didn't seem right. Oh, don't want to clear everything. Thank you. Ali fixed it for me. Good work. Virtual bonus points for you. Should be -3. I forgot to distribute my -1 completely. My bad. And that should be a 7 remainder then. Or a -7 remainder. Fix that up here. I'm going to blame the iPad. It was somehow the iPad's fault. I can't figure out why, but I'm sure it was. Okay, back to this one. Thank you, Ollie. So over here, again, what I'm trying to do is basically I'm going to take whatever that least common multiple was, and I'm going to put it in each of my numerators, okay? The reason I'm going to do that is because now look what happens. Gone. Gone. Okay? I get 8 minus x equals 5x minus 10. Okay, so my fractions are gone over on the left-hand side, and over on the right, all I did is distribute a property. Guys, once you get to here, just see what you got left, okay? I've got a pretty straightforward linear problem here, okay? So I'm going to subtract 8 and subtract 5x from both sides. Okay, I'm doing two things at once. I get -6x equals -18. Divide, I get x equals 3. Now, in these problems, technically we do have to look out for extraneous solutions. We have to look out for solutions that, even though we think we did everything right, still for some reason don't work, okay? But the only thing we have to look out for here is to make sure they don't make your denominator 0, okay? So if you kind of plug this back into the original, does it make your denominator 0? No. Okay, so you're totally fine. And you could do all the work of plugging it back in, and it would turn out just fine, okay? That's pretty much it on Unit 8 for fractions. I think it's definitely a unit that seems a little scarier than it actually is. It's a lot of, the issue with this one, guys, it's a lot of factoring, okay? So if you felt like you struggled on some of these or kind of struggled to keep up, especially on some of those earlier ones, a lot of your issues might be with factoring, okay? So make sure you go back and look at that if you weren't feeling particularly strong there. Okay, as always, if you have questions in person, make sure to, if something didn't get answered tonight, you can ask me in person, talk to me at school tomorrow. Hopefully this helped, and if you're watching this later, same deal, hope it helped. Come talk to me if you have additional questions. Ali, you said it right, buddy. #math.